There is the another type of law, quotient law. We have already discussed in your previous lecture the type of law. Product mean multiply and quotient mean division. Here the expression is in the form of division. It has also two types when bases are same and exponents are different. Let's see the example. You can see here 2 raised to power 7 divided by 2 raised to power 3, because quotient is the division, so we write it in the division form. When bases are same and exponents are different, 7 and 3 are exponents, so we just subtract their exponents and base remains unchanged. 7 minus 3, this will be equal to 4. Next, there is the example minus 2 over 3 to the raised power 5 divided by minus 2 over 3 to the raised power 5. You can write division form like this and this, both are same. So bases are same, we just subtract their exponents. 5 minus 2 and 5 minus 2 equal to 3. This will be our required answer. In general form, we deduce the law a raised to power m divided by a raised to power n. This will be equal to a raised to power m minus n. But here is the condition. M is greater and n is smaller. You can see here 7 is greater, 3 is smaller. 7 is m and 3 is n. Here 5 is greater and 2 is smaller. 5 is greater than 2. Here m is greater, n is smaller. Where this is the condition and a can never be 0. You can see here 2 can never be 0. Minus 2 over 3 can never be 0. We can't say minus 2 over 3 equal to 0. It will be never 0. 2 equal to 0. This is wrong. It can never be 0. So similarly here, this condition is most important where base a not equal to 0 and m should be greater than n. Okay, this is the condition of this law and you must write the condition with this law. Here, second type is when bases are different but exponents are same. Here is the rational number 2 over 3 to the raised power 4. This will be equal to, we can separate this as 2 raised to power 4 divided by 3 raised to power 4, or we can write this number as, this will be equal to, there is another p over q. We can write it in individual form, pq divided by q, where denominator can never be 0, because when we write here 0, so this rational number can never be defined. It will be undefined. So what is the definition of rational number? Rational number can be write in the form of p over q. And what is the condition? The denominator can never be 0. So we apply here, our denominator can never be 0. This is the important for this question. Okay, this rule is important. PQ divided by QQ. In general, we write when bases are different and exponents are same, a raised to power n divided by b raised to power n, this will be equal to a by b. We can write it in whole form, in single form, where b can never be 0 because our denominator can never be 0. So this is the law, two laws of a quotient law, and these law have conditions. This law have condition where a can never be 0 and m should be greater than n. And this law, when bases are different and exponents are same, this law have the condition b can never be 0. When our denominator is 0, so it will be undefined. We can never define this rational number.